Hello grade 11s and welcome to this video where we are going to discuss the quadratic number pattern. Okay, so quadratic number pattern, if you think of your sequences that it flows into in grade 7, 8 and 9, you did linear number patterns which has a first constant difference, and then we moved on into grade 11, although in our school we do it in grade 10 already. Is the quadratic number pattern, which has a second constant difference. Okay, and the cookie cutter mold, the other day I was teaching and one of the students, the new students, asked me, "Ma'am, what is a cookie cutter mold? What are you talking about?" I said, like, it's the original, like the basic one, which has in terms of A, B, and C, that one. Okay, so Tn is equal to and square and a burn and a C. All right, but in grade 12 you get that on your formula sheet, but you just need to remember that this is the quadratic number pattern. And something very, very important that we need to remember with the quadratic number pattern, it has a second constant difference. Okay. The linear number pattern that we did, just to quickly remind you, it was Tn is equal to Adeswa and Daniel sitting in a tree. N minus 1, that's the key. Okay, do you remember that one? Some of the students have another formula of how they write it. Just note that on the formula sheet, the D is always at the back. And I just tell my students, just move it there because we are used to distributing from the front. Okay, so that is what you've learned up to now. And then we are moving on to quadratic number patterns. Okay, so I always say, all right, let's look at a quadratic number pattern. So if I've got 6, 10, 18, and 30, we are going to quickly have a look what is being added the whole time. So if you don't know what is being added, you can always remember that it's term 3 or term 2. Let's start with the first one. Term 2 minus term 1. So we always start with the second one. Why? Because the first one we can't minus anything because there's nothing there to minus. So we start with the second one and we minus term 1. So 10 minus 6 gives you that we are adding 4. And I know this seems very basic and say, oh, but ma'am, can't we just say that from 6 to 10 we add 4? We can, but when we start using it in terms of x, it gets a little bit tricky. So you need to remember these, that also term 3 minus the previous one will be equal to those two. They'll give you, they won't be equal to yet. But how do we get the difference? Term 3 minus term 2. And that minus from each other, 18 minus 10 is a plus 8. And 30 minus 18 is plus 12. Am I right? Yes. Okay. Now that was your first difference. So can you see this pattern over here actually is a linear number pattern? So sometimes they ask you, calculate the 200th term of the first difference linear number pattern created by the quadratic number pattern. I know that's a mouthful, but it's this. Just remember that is a linear number pattern because after that it's got a constant difference. So remember, this was the first difference. Now we're moving over into our second constant difference, which is plus 4 every time. And can you see that that is a constant? Okay, so it won't, it will always end up in a second constant difference. Now, if you replace a term 1's value, let's just get a color over here. If you replace into your Tn is equal to and square and a burn and a C. If you go put in term 1's value in terms of A, B, and C, can you see that you'll end up, so if I replace everywhere where the N is a 1, I will end up with this pattern in terms of A, B, and C, or this equation. A, 1 squared is 1, 1 times A is A. A plus B plus C, because 1 times B is also B. So term 1's value over here in terms of A, B, and C is A plus B plus C, and that is equal to 6. So that is your first equation that you are getting when we are trying to find the value of A, B, and C in this quadratic number pattern. So let's do the same for term 2. So if I replace a 2 in here, so everywhere here there's an N, I'm going to replace it with a 2. So let me write it out. Okay, so term 2 is equal to 2 squared, which is 4a plus 2b plus c. And that is your second term's equation. So over here, 4a plus 2b plus c is equal to 10. So we are creating little equations everywhere. Now we're going to do the same with term 3. Term 3, I'm just going to do it immediately. 3 squared is 9 times a is 9a plus 3b plus c. Okay, so 9a plus 3b plus c will give you 18. All right, but now can you see if we say that term 2 minus term 1 gave me this 4, ne? 10 minus 6 is 4. So if I do it the same with my equations in terms of a, b, and c, if I say 4a plus 2b plus c minus a plus b plus c, I'm going to get this first differences equation in terms of a, b, and c. So 4a minus a gives me 3a. 2b minus b gives me positive b, and c minus c falls away. So 3a plus b is equal to 4. Now I'm going to do it the same for here. 9a minus 4a is 5a, plus 3b minus 2b is just a b, and the c's fall away, and that is equal to 8. And now if I carry that on again, remember, how did I get the second constant difference? I said 8 minus 4 gives me 4. So now I'm going to do it the same with my in terms of equation. 5a minus 3a is 2a, and b minus b falls away. So you'll always end up with 2a is equal to your second constant difference. Okay, so now I'm just going to make space so that we can stay on this page. Now we're going to write up those equations that we've gotten. So now, remember, our whole aim for this is to find the value of A, B, and C, so that we can go and replace it into our cookie cutter mold. There's that word again. So that we can create our general rule for this number pattern. Okay, so A is easy to find. We're going to start with this one at the bottom. So 2a is equal to 4. And if I divide on with 2 on each side, I get A is 2. Okay, cha-ching. So now we've got A2. Now I go to this equation that I created. And please note that these will always be the same. 2a will always end up being 2a. Here, it will always be 3a plus b is your second constant difference. Here, these equations here will always be the same, the ones in blue. Okay, so just so that you know, some students just remember it off by heart, but sometimes if you've been away from your books for so long and now you write about it, it's hard to remember it. Then you can just go plug it in. Term 1, a 1 everywhere where the n is, then a 2, then a 3, and you can create your own equations as you go. Okay, so 2a is equal to 2. Then our next equation, 3a plus b was equal to what? 4. But wait a minute, we know now a's value. Okay, so it's 6 plus b is equal to 4. So b is equal to 4 minus 6, which is negative 2. And now we go to our last equation. The others we just used to get to our next equation. Okay, so we write those up. Yes, we do, but we don't use them at the end. You can go and use them, but I always use the first 3 as it's formed here. Okay, so a plus b plus c is equal to what? Is equal to 6. A's value is 2. B's value is minus 2. And c's value then would be 2 minus 2. So c is equal to 6. Okay, now I'm going to write up my cookie cutter mold. So from my cookie cutter mold, I'm going to replace the A with 2, the B with -2, and the C with a positive 6. So this will be my equation for this number pattern. Tn is equal to 2n squared minus 2n, because the B was a -2, plus 6. All right. Okay, now we want to go and test it. Don't just, I always say to my students, don't think, ignorance is bliss. Rather go test it. So if I replace a 1, term 1's value is 6. So if I replace a 1 in there and a 1 everywhere, my answer should give me a 6. 1 squared is 1 times 2 is 2, minus 2 plus 6. Oh, thank goodness, it gives me 6. But let's just try it again. Let's see if I replace a 2 in there. Why? Because this 10 over here is term 2. So if I replace a 2 in there, again, that's the first term. This is the second term. That's why it's term 2. So if I replace term 2 everywhere, a 2 into the n's value, I'm going to get 2n squared. There's my cookie cutter, my general term that I've calculated. So term 2, everywhere where you see an n, if you replace it with a 2, you should get 2 squared is 4, 4 times 2 is 8, minus 4 plus 6. 8 minus 4 is 4, plus 6 is 10. Woohoo! Is it a 10? Yes! Okay, so now you can sort of say with conviction that your general term over here is correct. Okay, and now we're going to look at questions that follow. So that, everything that was just to find our general term. So if they say calculate the general term, that is what you're going to do. Then you get questions like this. So A, calculate the general term. Okay, so we did that. It's this one over here. Tn is equal to minus 2n plus 6. Minus 2n plus 6. And now they can ask you a question like this. They can say calculate the value of the 15th term, and that is very, very easy. We're just going to replace everywhere where we see an n with a 15. And then term 15 will give you 426. Okay, now they can also ask you a question like this. All right, so they can say calculate which term will have a value of 186. So now we're going to replace the Tn's value with 186 minus 2n plus 6. Okay, so we write it up and we are looking for n. So can you see that this is going to be a quadratic equation that we need to solve? Something squared, something n, just a number. So we'll always get two values for n. One is a positive and one will be a negative. Okay, so now you just need to always say, or you need to remember that we always just write the positive term. The negative term, we're going to say not applicable. We're just going to use the positive. Okay, so with these ones, can you see I can somewhat divide by 2 all throughout, just to make it a bit easier. 93 is equal to n squared minus n plus 3. And then you want to always equal it to 0. And plus 3 minus 93 is minus 90. Okay, if you need to, you can ask your calculator, if you've got a fancy calculator like the white one, or the silver one is also still fine. He can do quadratic equations. He can solve it for you. Okay, and that's why we always recommend that you have it. So if you have it, you can say shift mode. Sorry, you're going to say mode setup. 5, 3 for equation, your quadratic. Your A's value is 1. Your B's value is -1. And your C's value is -90. So then you would get this. If you had to factorize it, you would get that. They are different. Sorry, that one. They're different. The first one's a minus. Or if you just plugged it into your calculator, you will get that n is equal to either 10 or n is equal to -9. So we're not actually testing here whether you can factorize, so you can actually just pop it into your calculator and get those two answers. Okay, so then again, we're going to say this one is not applicable, thus n is equal to 10. So we never have a negative answer as our term, which term number has a value of. All right. So I'm going to make 2 videos on this. This is just the straightforward how to get the equation. And then I want to show you where we have a value of x. So one of the term values are not there. We have an x instead of one of the terms. And how do we go about using that? So people, this should give you a good idea of how to find a general term. Please make sure that you've got these blue equations. You can learn it off by heart, but the best way is just to go plug it in and then see what it comes to. So that when you get to the exam, that you don't say, oh no, I forgot that, or you didn't remember the correct formula, now your whole thing is wrong. Rather learn it like I've showed you here, so that whenever you forget what the equation is, you can still derive it from replacing a 1, a 2, and a 3 into your cookie cutter mold. Okay, thank you so much for watching grade 11s. Watch out for the next video on this one, and I hope you have a wonderful day. Thanks, bye.